We're going to start looking at how to describe motion, and the first idea that we need to do in looking at that is a frame of reference. So let's jump right into it. So first of all, we're going to define a frame of reference, and this is how the motion of an object is described. Depends on who or what is measuring. So if we're going to talk about frame of reference, that's because the motion depends on kind of how you're observing it. So as an example here, if I were, say, had a bus traveling down the street, so imagine this is the bus here, and if there's a person on that bus and they throw a ball and it goes up and comes down and they catch it, from their frame of reference or anyone else on the bus, to them it looks like the ball went up and came back down. But now, if we imagine someone who's standing on the street outside the bus, from their perspective or their frame of reference, they see the ball go through this path instead. So this is the bus kind of moving forward. This is a rough sketch. So at the beginning, the ball was in their hand. Halfway through, the ball is at the highest point, and then it's back in their hand. So from their perspective, the ball kind of goes through this arc, and imagine I crossed through this ball. But they see the ball go up and forward and then come back down. Now, yes, they recognize it's not going to move relative to the person, but from them actually observing what they see, this is what they see, the ball traveling in this arc. So if we want to define a frame of reference, that is the set of coordinates or reference points from which a measurement is taken. So in that example on the last slide, one reference point might be the bus. So measuring everything relative to the bus. So if we put a grid on the ground of the bus and measured things there, we'd see that the ball just goes up and comes back down. It doesn't move forward or backwards. Another frame of reference might be the street. So if we put lines on the street, made a grid on the street, then we would see that ball move horizontally in that case. Understanding frames of reference is important because it determines if two observations agree or not. So we're going to all observe different things, but we need to decide if those observations agree or not. Because if they agree, we can say, okay, here's what happened. If they don't agree or we can't reconcile them, then we need to collect more data and figure out what happened. If we want to convert between reference frames, we simply add or subtract the relative positions or speed. So if one person is measuring things from the top of the cliff and one person's measuring from the bottom of a cliff, then all we have to do is add or subtract the difference in the cliff height. Likewise, in that first example, if someone's on the bus versus someone standing next to the bus, all we have to do is add or subtract the velocity of the bus to kind of reconcile this. And you'll play with this, you'll get more comfortable as you practice problems, or if you're still a little unsure when you do that, ask me and I'll be happy to help. So last thing I want to say about reference frames is there is no objective or correct reference frame. All reference frames, nothing is more correct than another. All reference frames are equally valid to take measurements from. What's important, though, is that they agree. So it's important that we can get them to match up. We can say, okay, if I'm thinking about agreeing, that means if I imagine I was in your reference frame, do I think I should get the same measurements? So the person standing next to the bus, watching it go by, they see the ball go up and down, but if they watch, and they say, oh, it's always right above your hand at every point along the way. In other words, the movement of the ball to the side matches the movement of the speed of the bus to the side, then they'd say, oh, I would agree with you if you said I threw the ball, it went straight up and came straight back down. Likewise, if you're on the bus and you say, I saw the ball go straight up and come straight down, but at the same time you're looking out the window and you see the ball, moves across points on the sidewalk or across, lines on the pavement, you would say, oh, I agree that you would see the ball traveling in this arc. So that's what we want to focus on. Let me know if you have any further questions.